In this video, we will examine the basic question of what is linear programming. Linear programming is a sequence of steps that solves a problem that involves limitations. In earlier lectures, we talked about the linear trend equation, which was all about using lines to make forecasts. Now, we're going to be using lines to solve problems through limitations. This will all become much more clear as you follow this video series with your textbook. Okay, so when will we use linear programming? Let's go through 4 examples when linear programming would be useful to help solve the problem. One typical logistic type question would be, how much should be shipped from a warehouse to its distribution centers to meet demand at the least cost? Here, our goal is to minimize cost while subject to meeting the demands of the distribution centers and shipping no more than the supply of the warehouse. These are the restrictions to the problem, which we refer to as constraints. Another type of problem you encounter, and which will be really important for you to become familiar with, deals with product mix. In these types of questions, we have limited resources which needs to be allocated to maximize profits or to reduce costs. Here, our goal, which is referred to as the objective function, is to either maximize profits or to minimize costs. In this case, we are constrained by our limited resources of equipment, labor, materials, and as well as our marketing constraints. These last 2 I'll go through fairly quickly. A personnel scheduling type problem would be, how might we schedule personnel to minimize costs, subject to meeting personnel requirements for each shift and labor laws? Now, when you hear the words subject to, it is usually a hint that what follows will be the constraints to the problem. And finally, when looking at a capital budgeting type question, we might be evaluating different projects to decide which one is worth investing in, subject to their expected returns and yearly investment. Obviously here, our goal would be to maximize returns, which would be subject to our yearly available funds. Alright, so we've seen some of these terms already, but let's go through them again. As we said before, the objective function is the goal of the problem. Are we trying to maximize profits, or are we trying to maybe reduce costs? Decision variables are decisions that you can make. Should we ship more products, or should we ship less? Should our employees work longer hours, or should they work less? As we saw from our past examples, constraints are what we are subjected to, or what we are limited to. After all, there's only so many hours in a day. And what we see here are the 3 components necessary to solve a linear programming problem. The terms below are more conceptual and will probably make more sense once we go through a problem together. A linear function, like its name implies, means that we will be dealing with lines to identify all the feasible combination of decision variables as defined by our constraints. And then finally, we will look at this space and identify which combination brings us closest to our goal. These are referred to as the feasible solution space and the optimal solution. And before we get into the hows, we need to quickly talk about the assumptions that must be satisfied in order for a linear program to work. Again, this material will become much more clear when we go through an example together. First, like the name of this method implies, we are assuming that our goals and constraints are linear. Second, our parameters to our constraints are known. And finally, our decision variable can have a non-integer value, but it cannot have a negative one. And again, I want to remind you that this will become much more self-explanatory when we do an example together.